planes intersect that?
What line?
Yeah. Like the ceiling and the wall intersect on okay. Brianna, a line and a point not on that line are in exactly one what? Yes, they're in one plane. They're covered by exactly one plane. This is the tricky one. you know it? Okay, what is it?
Three non-collinear points.
Yeah, non-collinear. Remember, I said you had to use like 3 points to name a plane, but yeah, they're non-collinear points. They can't be in a line because
It can be on both.
if you have 3 points in a line, there's a lot of planes that intersect it. Those 3 points, but if they're non-collinear, there's only one plane that can cover them. Okay. Toby, if 2 points are in a plane, then the line containing those points, what? If 2 points are in a plane, then what can we say about the line that has those 2 points? Anybody know this one? Okay, is also in the plane. If 2 points are in a plane, if you think about it, it makes sense. The line containing those points is in the same plane. It's like if 2 dots are in a piece of paper, then the line that goes through the 2 dots also has to be on the piece of paper. Basically what it means. All right. Okay, Hunter, intersecting lines intersect at 1 point. I should have left the whole thing blank. That one was the easy one. Okay, number 6 is next. Name all angles in the picture. Too many. Too many also. Yep. 6. Okay, so you might be saying the same angle twice, possibly. I don't know. There's 3 little angles. 1, 2, 3. There's a medium angle here. Medium angle here, and then the large angle. Okay, so Carter, what are some of the angles you got?
Angle 1, angle 2, angle 3.
Okay.
angle BAE. I did have the second one. I had EAB. And then there's angle EAC.
So, oh, did you say BAE on this one?
Yeah, BAE.
Yeah. Okay, that's the large angle, which is the same as EAB, but yeah. Go ahead.
Angle EAC.
Oops.
And EAD.
EAD. Yeah, angle EAD is angle 3. So you got the one you just said, EAC, that's this one. This is not angle 2 or angle 3.
It's angle BAD.
Right. So yeah, this one's made up of 2 little angles, and this one is also made up of 2 little angles. So yeah, angle BAD, BAD. So yeah, 6. Alright. Everybody's favorite questions. Not working. Technical difficulties. Need to highlight it first. No. It's bigger but not smaller. Let's save a copy of that. You guys distracted. Can't see the problem. Is that a problem? There. Fine. There. All right. Let's see. Ray AB. So it starts at A, goes through B. Kind of like that. And Ray BC. Starts at B, goes through C. James, what would the union of those two be?
Right AC.
Right. So union just means you combine it all together. So that just basically, this is a redundant, not necessary. So it's just Ray AC, or you could call it Ray AB. All right, and then, so this is Ray CB and Ray AB. time it's what is the intersection of those two rays?
Would it be line segment AC?
Right. So, somebody in another class said line AC. Why would that be wrong?
Because ray AB doesn't have, it's not going the other way, they have ups and points.
Yeah, well, it's because it's an intersection, not a union.
Who would say that? Gosh.
I mean, that's what you said. Yeah, if it was a union, it would be the whole line, because when you do the union, everybody's invited. The intersection means where do they intersect at? Where are they both at? So that would just be from there to there. So he said it right. He said segment AC. Segment AC is very different than line AC. You should probably stop playing with it. Okay, anyways, that's that. And then there's number 8. I feel like 8's easier, but I think John in the other class said these are the ones he gets wrong. What do you do? All right, Corbin, what's the union of half plane 1, half plane 2, and line K?
Would it just be plain P?
Yes. Plane P, the whole thing, the whole plane, so, yeah. Plane P, you just put P, is fine. Miranda, do you remember what this little symbol right here means? It's the complement, but more importantly, what does complement mean? It means what's not in that. So, if you got half plane H1 and line K, what's the complement of that? What's not in those? Yeah, half plane H2. Okay. You guys remember these problems? So we got polygons and then polyhedron after that. So these are just examples on the test, but they're not the actual questions from the test. So you need to know all the polygon prefixes, not just this one. So triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, and remember I said you have to know 12 too, so that's dodecagon. All right, so Ashley, well, number 9 is a what?
Hexagon.
Hexagon, and is it concave or convex?
Convex.
Yeah, because it doesn't have any caves, basically. It's convex. And then Brooke, number 10.
It's not a polygon because it crosses.
Not a polygon because it crosses it. itself. Back to Luke. Luke? Number 11?
Not polygon.
Because...
It's not closed on.
Not what?
It's not closed.
Closed, yeah. Brianna, Ch1. How many sides does it have? Huh? 1, 2, 3, 4, 5, 6. So do you remember what that was called? Yep. Yeah, I shouldn't have done that, but it's the same as number 9, hexagon. Now, ironically, hexagon is not on the test, but there's one off your list. Hopefully now you know hexagon 6. It might be in the, maybe it's in the other section though, the polyhedron section. Is it concave or convex? Concave, because it has caves. Okay, it's concave because it has caves. If you guessed hexagon, it might have been because that was the answer to number 9. Uh-oh. That's not good. Back to life. There we go. Okay, I tried to draw this better, but I kind of failed. If I try and draw the lines in the back, it doesn't work. It doesn't look good. Yeah, I think I'm gonna mess with it. You also have to use your imagination for the lines in the back. Okay, so classify this cylinder or cone. I don't really like the way they say these directions, but that is the way they said it in the book and on the test side. It doesn't mean all of these are cylinders or cones.
Is number 14 supposed to be 3D?
Yeah, these are all 3D.
Okay.
That doesn't look 3D to you?
Well, is it supposed to have like the dotted lines on the other side?
Yeah.
Okay.
I did draw the dotted lines at first, but then they like overlapped with the front lines, so it doesn't look very good.
Yeah.
And so I just threw them out. So you have to use your imagination. If I would have drawn it longer, it would have looked okay. Okay, Lauren, what do you think? Okay, so you have to classify it as, based on its shape, like what's the best name. And if it's a polyhedron, also based on the number of sides. So, what do you think this one is? Not a cone. Yeah, if all the edges are flat, or straight edges, all the sides are flat, it's a pyramid. And what kind of pyramid is it though? You gotta be more specific. What shape is the base? Triangle. So it's a triangular flat surfaces, so it's a polyhedron. So how many sides does it have?
Is it 1, 2,
No.
4?
4 if you count the base, right? Okay, 4, and do you remember, 4 was the weird prefix for poly, does anybody remember?
Tetrahedron?
Tetrahedron. So that one was the hard one to remember, because everything else is pentahedron, hexahedron, anyway, it's the same prefixes for polygons after tetrahedron. Okay. Toby, any ideas what 14 is? Let's start with the base. Do you know what shape this is? Hexagon. Okay, now if you have like a hexagon on one side and a matching hexagon on the other, do you know what that's called? It's called a prism. So this will be a hexagonal prism. Okay, now let's think about prisms for a second. Now this is basically a rectangular prism. It's a little bit off, right? But it's got a rectangle on the base. So from each of these 4 sides of the rectangle, there's a lateral surface coming up. Because the base has 4 edges, there's 4 sides coming up. And then there's a top and a bottom. So this has 6 sides, 6 faces. Okay, so if there's 6 edges on this base, how many lateral faces are there? 6. And then there's a base here, and then you can't see it, but it's in the back. There's a base on the other side. So it's basically 6 plus 2 is 8. So if it's got 8 sides, it's called do you remember what's prefix for 8? Yeah, octahedron. Usually people remember the octa because octopus, I guess, I don't know. Or maybe it's just a famous common shape, I don't know why. But yeah, on the 3D it's octahedron. Alright, Hunter, what's 15?
Cylinder.
Cylinder. They would call it a circular cylinder because normally when we say cylinder, we mean it's a circle. But by the book's definition, it could be irregular bases, not necessarily circles. But yeah, I would take cylinder. And it's not a polyhedron because it's not flat surfaces. All right. So, Carter, 16. It's cone. Not a circular cone, but still a cone. All right, same thing. Not only one answer. All right. This is the part I feel like people might make this too hard.
Yep.
Oh, I wanted to change it to make it come out right, but hold on, let me think about this for a second. Oh, well. If I make this a 5, that would be pretty big. Right, because right now the way I have it set up, the number, it comes out as a fraction, and I don't want it to be a fraction. Let's see. Maybe if I just put a +5 here, that'll probably fix it. So they said AC is 92. Here's AC. That means the length is 92, whatever it is. I don't know, centimeters, something. Okay, AC is 92. We have AB is this, BC is this. So what's the relationship between these three things?
They're on the same lot.
That's not what I'm looking for. I'm trying to solve for X, so how can I set this up to help me figure out what X is?
2x minus 5 plus 3x plus 5 equals 92.
Yeah. If the whole thing is 92 from here to here, then this plus this equals that. This little thing plus this little thing equals all of it. So this plus this equals that. You gotta do some algebra. You guys have been missing algebra.
Did you say the answer won't come out as a fraction?
Hold on, let me check again.
It will.
See, it's plus 15 minus 2. Oh, shoot. Okay, I should just change this number. That would have fixed it. Let's make it a 95.
That's
All healed. Okay, so now everybody, you guys remember we did this. You just distribute the 2 and distribute the 3. Should ask you if you remember what distributive property was. Let's multiply it out. Let's see. Think what would we do at this point?
You combine like terms.
Yeah, 2x plus 3x is 5x. Minus 10 plus 15.
Plus 5. You need to subtract 5 and then divide by 5.
Let's see, that'd be 18. Alright, is that the answer? No. We're looking for this. AB just means the length of AB and the length of BC. Segment AB and BC. So how do I find the length of segment AB, or segment AB?
18 is for x.
Right, now that we have X, we can put it right there. So 18 minus 5 is 13 times 2. This one's a lot smaller. Picture's not accurate. So yeah, it'd be 13 times 2, so it'd be 26. Now you can plug in 18 right there to get BC, or you could do 95 minus 26, because together they have to make up 95. All right. You guys think you can do that tomorrow? Even if you're not sure, go ahead and try, and if you get close, I can maybe give you some partial credit on it. All right, very similar. This is separated here. What do I know about angles 1, 2, and 3? Corbin, do you know? What do I know about angle 1, 2, and 3 on this?
they're all deep.
Yeah, maybe, but what else do I know? Together, what do they make?
180.
180. So that means, do you guys know what this little M is right here? Measurement. So it doesn't really mean much. It just means we're talking about a number not the angle itself, but the number that measures the angle. But yeah, you can kind of ignore that. So these represent the three angles. So these three should add up to 180. Because when you have a straight angle, it has to be 180. So these three together add up to 180. We did something kind of like this on the review. So anyway, it's 3x plus 5 plus 2, 2x plus 4 plus x plus 13 equals 180. And then at this point, it's pretty much the same as the last problem. You add all your, well, distribute and add your like terms together. So we have 3x plus 4x plus 1x is 8x. And 5 plus 8, 13 plus 13 is 26. This one should come out right? I'm trying to fix it. Let's see. If you subtract 26, I don't think they would put a decimal or fraction on the test, but I don't remember for sure. Let's see, this would be 154 divided by 8. No. Nah. I thought I fixed it. I was wrong. 5, 8, 13, yeah. Okay. If I would have made this 15, then this would have been 28, and this would have been minus 28, and this would have been 150. Okay, that would have worked. Okay. I think this is 19, right? Anyway, once you get x, you need to plug it back in here to find angles 1, 2, and 3. And yeah. So if x is 19, 3 times 19 plus 5 is 57, plus 5 is 62. And 19 times 2 is 38, plus 4 is 42, times 2. You could do 180 minus those two to find that. Or, put it right here, 19 plus 15. All right, any questions on that one? All right. I was kind of in a hurry at the end here because we were running out of time. So, let's get that out of the way. All right, so I just said name any two, there's a lot of possible answers. Name two parallel lines in this picture.
Those be line segments.
Hmm?
Are those lines or line segments?
In the picture, they're line segments, but it does say name lines. The line segments are part of the bigger line that you can't see necessarily. Well, you can't see an infinite line, but it does say lines, even though the drawing is of segments. Okay. I think did I ask Corbin a question already? So Miranda, can you give me an example of two parallel lines?
A, B, C,
my writing's not perfect. Here, Brandon.
Oh, thanks.
Is that big enough for you? Sorry, I get distracted. Alright, yeah, that was a good example. A, B, and C. Yes. Did we talk about the parallel symbol? I think I might maybe mentioned it once. You don't have to write it, but it's just two vertical lines. Okay. Ashley, two parallel planes. Okay, A, B, C, D. Now I kind of wrote it wrong because when you say like a rectangle, even though it's plane it doesn't really matter. But when you name like a shape, it should be in order, like A, B, D, C. Like you have to go in order. But since we're talking about a plane, I guess it doesn't matter. So A, B, C, D, E, F, G, H. That is one example of, well, how many examples are there? 3, I guess. E, F, G, H. One possible answer. All right, skew. We haven't used this word a lot. Does anybody remember what it was? Not diagonal. It means they don't touch, but they're not on the same plane. So they're not parallel. They don't touch, but they're not parallel.
So diagonal typically be parallel.
Well, they don't have to be diagonals. Like, okay, if I said line AB, what's another line that does not touch that, but is not parallel? Huh? FG? Actually, these two would be parallel. Even though they didn't draw the plane in the picture, there is kind of a plane that would connect those two, so these two actually are kind of parallel. So, does anybody else have an idea?
CG.
CG, yeah, that'd be it. So, are these two gonna touch ever? No. Are they parallel? No, this one's going up, this one's going towards us. So these are not parallel, they're called skew. So, oh yeah, there's a lot of possible answers on these. Should we call that good? Oh, perimeter's also on the test. I thought I'd throw a few easy ones in there. Hopefully, in theory.